An astronomical telescope is in normal adjustment. The diameter of incident light beam falling on the objective is d. If the angular magnification of telescope is simple m, the diameter of the emerged beam is. You know that we are observing objects at infinity by using telescope. Therefore, incident rays are parallel. This diameter is given as d. This one is the objective length. Focal length of objective lens is f4. And there is an image at this place. And for the normal adjustment of telescope, we have to get final image at the infinity again. Therefore, again, faces are parallel to each other. We have to find this diameter, capital D. This one is the eyepiece lens. Focal length of eyepiece lens is Fe. And we know that Fe is less than F4 for the telescope. And we can write angular magnification for the normal adjustment is F4 divided by Fe. Then I will get this distance is the focal length of objective lens. Parallel rays are meeting at this place. And this distance is focal length of eyepiece lens. Then we can get this triangle and this triangle, equiangular triangles. Then capital D divided by Fe equals to simple D divided by F4. Then I will subject capital D. It is D multiplied by Fe over F4. Fe over F4 means reciprocal of angular magnification. Then we can get D divided by simple M. Then answer is 1. An astronomical telescope contains of two convex lenses of focal length 50 millimeters and 650 millimeters. The moon subtends an angle 0.5 degrees on an unaided eye. If the telescope is used to normal adjustment to view the moon, the angle subtended by the image of the moon of the eye is. Angular magnification for the normal adjustment is, it is capital M. We are normally using capital M. In this problem, they have given simple M, but we are using capital M. It is F4 over Fe, and we know that it is alpha divided by beta. Alpha means angle subtended by the final image. Beta means that angle subtended by the object on naked eye. Then F4 value is the larger focal length. It is 650 millimeters divided by Fe value is 50 millimeters. There are same units. Therefore, we can use without a unit conversion. And we have to find alpha, the angle formed by the final image. Beta is given as 0.5 degrees. 5 divided by 5, 1, 13. 13 times 5, 65, 6.5 degrees. Then answer is 1. The focal length of the lens of a simple microscope is 10 centimeters. If near point of an eye is 25, approximate value of the object distance required to obtain the maximum angular magnification. We know that we can observe maximum angular magnification when making final image at d distance. D means near point of distinction for any type of optical instrument. Then we can get lens formula for the simple microscope. Simple microscope means hand lens. 1 over V minus 1 over U equals 1 over A. Image should be formed at 25 centimeters. It is a plus value. Because of when considering hand lens, image is at this side. Light rays are moving in this direction, we have to measure opposite direction, therefore it is a plus value. We have to find object distance, corresponding object distance. Focal length is given as 10, it is minus 10 because of simple microscope is a convex lens. Then we can find U value, 1 over 25 plus 1 over 10 equals 1 over U. LCM 50, 50 divided by 25 2 plus 50 divided by 10 5. We have to find approximate value. 50 divided by 7, approximately 7 centimeters. Then we can get third one is the correct answer. The planet Mars subtended an angle 18 to 10 to the power minus 5 radian at an unaided eye. When the Mars is viewed using astronomical telescope in normal adjustment, is subtend an angle 2.4 into 10 to the power minus 3 radian at the eye. If the focal length of eyepiece is 0.03, the focal length of objective is. Again we can get angular magnification is f4 divided by fp, focal length of objective lens divided by focal length of eyepiece lens, and it is equal to alpha divided by beta. Focal length of eyepiece lens is given as 0.03 meters. We have to find focal length of objective lens. Alpha is the angle subtended by final image. It is 2.4 into 10 to the power minus 3. Beta is the angle subtended by the object. It is given as 18 to 10 to the power minus 5. Then we can simplify it. F naught equals 8 divided by 8 1, 0.3, 3 into 3 9, 1, 2, 3 decimal places, 10 to the power minus 3 and 10 to the power minus 5 cancelling out. 10 to the power minus 3 divided by this one is 10 to the power minus 2. Then it is 10 to the power minus 1, 0.9 meters. Then answer is fourth one. Astronomical telescope has objective length of focal length f naught and eyepiece of focal length fp. If the telescope is in normal adjustment, the total length and the magnifying power of the telescope are given by. We know that for the normal adjustment, length of the instrument, it means gap between two lenses are sum of focal length. This one is the length of the instrument. And magnification, angular magnification for the normal adjustment of telescope is f4 over fp. Then we can get fifth one is the correct answer. A telescope having a magnifying power 15 has an eyepiece of power 15 diopters. The length of the telescope when it is in normal adjustment. Again, magnifying power is f4 over fp. It is given as 15. Power of eyepiece is 50 diopters. Power of eyepiece means 1 over fp, but we have to consider that if this one is the power, when getting power in diopters, we have to use focal length in meters. Then f naught into 1 over fp means 50 diopters. It is in meters. It should be equal to 15. Then we can obtain f4 is 15 over 50. It is in meters. When converting to centimeters, we can multiply this value by 100. Then 50 divided by 51 to 30 centimeters. And we know that length of the instrument is f4 plus fp. Then we can get length of the instrument f4 30 plus fe value 1 over 50 meters. It is this value in centimeters. Then 32 centimeters. We can get the correct answer is fourth one. Final image of compound microscope at normal adjustment is. For the compound microscope, we know that first image will form due to this object. Object distance should be greater than focal length of objective length. Then an image will form at this place. And this one should be object distance for the second lens. It means eyepiece length should be less than focal length of eyepiece length. Then we can obtain final image at G distance. It is like this. Now you can understand this image is formed by producing light rays in opposite direction. Therefore, it is a virtual image. Virtual. Final image virtual. And inverted. Larger than the object. It means magnified. Then answer is 1. Consider the following statements made about the compound microscope. Statement A. Object should be placed just outside the focal point of the objective. Yes, it is correct. Just outside the focal point of objective. B. The eyepiece acts as a simple magnifier. Yes, for the simple magnifier means hand lens. For the hand lens, we can observe that an image like an object like this will magnify in same direction, and there is no an inversion. Then B is correct. Then statement C, the angular magnification is independent of the focal length of objective. It is false. For any instrument, optical instrument, magnification is depending both lenses. Then A and B, only A and B are correct. Then answer is 2. Which of the following statements is not true with regard to compound microscope? Not true. It has 2 convex lenses. Yes, it is correct. 2. Image of the object formed by objective is real. Image formed by objective means this image. It is real. Yes, it is correct. Then separation of lenses is much greater than the focal length of objective or eyepiece. Yes, it also correct. Separation is greater than focal length. Then part 4, final image formed by microscope is virtual. Yes, it is correct. This one is a virtual image. 5th one, the object we examined should be placed within the focal length of objective. No, we have to place it such that object distance is greater than f0. Then answer is 5. Consider the following statements made regarding the optical instrument. A. Simple microscope has a single convex lens, and when in normal adjustment, the microscope produces a virtual image at the least distance of distinct vision. Yes, it is correct. For a simple microscope, we are using only one convex lens. Its image is like this. Object image. Therefore, we have to produce light rays in opposite direction. It means it is a virtual image. B. Compound microscope has two convex lenses and when in normal adjustment, microscope produces virtual image at infinity. No, for the normal adjustment, final image should be formed at d distance. Part C. Astronomical telescope has two convex lenses and when in normal adjustment, the telescope produces a real image at infinity. No, the image formed at infinity is a virtual one, not a real image. Then only A is true. Answer is 1.